Hi everyone, this is for Geometry Advanced students. This is your Midterm 1 review, Part 2 of your midterm review for the test. I am going to be going over the math packet, the midterm review packet that you were passed out in your classes from your teachers. So let's get started. So midterm review packet, these are multiple choice, this first part. So for this right here, you've got which law is being demonstrated. So if M happens, then it's a conditional. Then T does not happen. So T did happen, so therefore M did not happen. So that's your deny, two denials. That's your tolendotonin. So the next one is what type of sentence is this right here? So even though it does have a conditional in it, that conditional is inside these parentheses right here. Likewise, your conjunction is also inside. But because whatever is outside of these parentheses is your major strength, that's your connective that has the strength, this is going to be a negation because the negation is outside. This one is saying, which of the following is the antecedent? So the antecedent is the first part of the conditional. So your antecedent would be just A. What type of sentence is this? Now you should notice that there are no parentheses in this equation or in this sentence. So it does have a conditional and it does have a conjunction, which basically means which one has the more strength, a conditional or a conjunction. And your answer should be a conditional. Okay, and then this one says, using the laws of strength, add parentheses where it is needed to make it a conjunction. So they want it to be a conjunction, which is this. So that means that whatever happens, that has to be outside of the parentheses. So if they want that right here, so that means this is going to be inside parentheses like that for that to be outside. So what letter is that? It must be, that's here, C. The next question is a proof, and this is a logic proof. You will not be given these rules of, you're not going to be given these rules. So you will have to know those rules, and that's something that you should study by either looking over your homework packet, looking over your tests, etc. You need to look through that. So let's see what we're trying to prove. We're trying to prove that T and S happened. So we know that if E happened, then S happened, and that's my premise. We also know that if T didn't happen, then J did not happen. Another premise. But remember, we do want T to happen. So that's not right. So we know that E and J happened, and that's a premise also. So now what we need to decide is because I gave you the statements, what are my reasons for this? And you don't have to write your line numbers. All you have to do, or your line of references, all you have to do is give me the reason for this happening. So the first one, we know that E and J happened, so therefore E happened. That's just simplification. Okay, and simplification, what letter is that? That's what, AD? So that's AD. The next one says, well, if E, let's go back. So E and J happened. So go back up here. See, if E happens, then S happens. So we know that E happened, therefore S happened, ponendoponin, and that's A, okay. And I'm saying A because that's what this is, that line A. So we know, let's go back. E and J happened. E happened. So going back up to the first premise, if E happens, then S happens. So we know S happened. We know J happened because this says both E and J happened. So J happened, that's another simplification. And you would just write AD here. The next question said, so if I know that, what do I know? I know J happened because E and J happened. So here, this says if T didn't happen, then J didn't happen. So we know that J happened, so therefore T had to happen. So that's tolendotonin. And what is that? AC. So therefore, I know that T happened, and I know S happened, so they both happened. So I'm adding them together. That's called adjunction. And I don't know what number that is. Rule E. So that would be rule E. Okay? Free response. It says that the measure of KSH is equal to 4x minus 10. LSH, okay, LSH, which is this, is equal to 3x. I know that SH, which is this ray right here, bisects KSL. Oh, well, if it bisects it, then these are congruent. So find all the measures of the angle. So we know that 4x minus 10 is equal to 3x. I'm going to subtract 3x, I get x. I'm going to add 10, I get x equals 10. So, but that's not an answer. Don't put that as an answer. That's not an answer. They want the angles. So I'm going to put in the angles. So what I do know is if x is 10 for this angle, 3 times 10 is 30. So that's 30 because they're the same angle. But if you're paranoid about getting the wrong answer, you can also plug 4 times 10, 40, minus 10, I get 30 again. So they want KSH, so what's that, 30 degrees, and HSL, another 30 degrees, and then we have a 60 degrees. Contrapositive, the contrapositive. So the contrapositive is the converse of the inverse, okay? If P happens, then Q happens. So that's going to be if Q doesn't happen, then P doesn't happen. True. So what's the converse of the contrapositive? The converse of the contrapositive? So the converse of the contrapositive, well, we know the contrapositive is this. So the converse would be if not P, then not Q. All right. Okay, what do we know here? AD, where's A? AD is perpendicular to FC. Okay, I'm going to make a right angle there. Angle 1 is 38 degrees. Okay, we know that's 38 degrees because those are vertical angles. Let's see, we know that BDA, this angle here. So we know that that's a right angle. What's 90 degrees minus 38? Okay, so just borrow 9, 8. That's what, 52 degrees. This right here is 52 degrees. Okay, we know this is 90. So what do we want to know? Fill in the blanks. Angle ADF, so ADF, so that's 90. All right, we know that EDC, okay, let me see, EDC, oh, this angle here. That angle, if this angle is 38, that angle is going to be 180 minus 38 degrees. What's that, 142? So EDC is 142. CDB, well, that's 38 degrees. And ADB, 52 degrees. Okay. The next question, oh, this is a proof. This is actually not my favorite proof, I have to say that. I mean, it's not hard, it's just a lot of writing. Okay, so ST is perpendicular to TU. Hold on. ST and TU. Where's TU? Oh, these two are perpendicular. So ST, so that's perpendicular. We also know that RST is a right angle, so that's also a right angle. Well, if something is a right angle, by the way, that means it does equal 90 degrees, and that's the definition of a right angle. We're going to hold that thought. We also know that angle 2 is congruent to angle 3. All right, so I'm trying to prove that 1 is equal to 4. And so what I'm going to do is something like this. My thoughts are, I'm going to go 1 plus 2, because it's a right angle, right? Because perpendicular lines form right angles, right? 1 plus 2 is going to equal 3 plus 4, because those are both right angles. Right angles are equal to each other, so I can then say 1 plus 2 equals 3 plus 4. I know that 2 is equal to 3. So those are the same angles. So I'm actually going to subtract off of the big angle, and now I'm going to have left 1 equals to 4. So that's my idea behind this. Let's see if I can do this in less steps than the 9, but we'll see. So we know that ST is perpendicular to TU. okay? We know that angle RST is a right angle. I know that angle 2 is congruent to angle 3, and that's all given, okay? The next thing we want to say is, in this, we want to say that the measure of angle RST, so RST, is equal to 90 degrees. And I want to say that's the definition of a right angle. I may need to say that, let's see, the measure of angle 2 is equal to the measure of angle 3. I know I already said that, but just saying because of this right here, see how I converted between a congruence and a measurement? Definition of congruence basically says that I can say the measure of angle 2 is equal to the measure of angle 3. I can just switch back and forth, and you would say that's the definition of congruence. Okay, so the next question says angle 1 and angle, so what do we know here? We know that these two angles add up to be 90, so 1 plus 2. We know that they're complementary, so we do want to say angle 1 plus, or 1 and angle 2 are complementary. If the exterior sides of acute and adjacent angles are perpendicular, then the angles are complementary. So this is what it's saying. See that line and this line right here? That's what they say. If the exterior lines of two angles that are complementary, if these lines here are perpendicular, then angle 1 and angle 2 are complementary. That's what that's saying. Okay, so it's like you write that out. You write that whole thing out. You say if the exterior sides of acute adjacent angles are perpendicular, which they are, then the angles are complementary. And you basically have to say that they add up to be 90 degrees, okay? So once we do say that, then I can say the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. And that is not this. They're not saying it's a right angle. I'm saying that those two angles, by the definition of complementary angles, I'm saying that those angles are, the sum of those angles is 90 degrees. I would then say we know that 1 plus 2 is 90. We also know that the measure of angle 3 plus the measure of angle 4 is equal to the bigger angle, RST. And that's just angle addition postulate. Okay. We also know that if RST right here is a right angle, then I can say the measure of angle 3 plus the measure of angle 4 is equal to 90 degrees. That's just the transitive property, but we actually would accept something other than that. As far as line numbers go, this is 3. Angle addition postulate, let's see here. Angle 3 plus angle 4 is 90. That's the transitive property. So that's what 2, 5, and what else do we have? Transitive property of equality, so that's a P. All right, number 7 says, well, we know that, this is what we know. We know that 1 plus 2 is 90. And we know that 3 plus 4 is 90. And this is what I was saying in the beginning. Okay, finally got around to saying that. So if those are both 90, we can set 90s equal to each other. And that's substitution property of equality. I'm going to say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure, these are equal, measure of angle 4. And that's the substitution property of equality. Let me fix that. Substitution property of equality, because what I'm doing is substituting 90 for angle 3 plus angle 4. We know that 2 and 3 are equal to each other, right? We said that here. So basically what I'm doing is I'm subtracting off 2 and 3 at the same time. So I'm going to have the measure of angle 1 is equal to the measure of angle 4. Subtraction, property of equality, and just reline this. Definition of congruence basically says then that I can say that angle 1 is congruent to angle 4, and you would just write definition of congruence. All right. So number 11 says if B is between A and C. So B is between. So we've got, here's A, here's C. B is somewhere in the middle. We don't know where it is. It could be in the middle to the left, it could be in the middle, it could be to the right. Which one's not possible? The only one, okay, so AB plus BC is equal to AC, totally possible. AB is greater than BC, I mean maybe. AB is equal to BC, well if B is in the middle, then that could work. AB is less than AC, that works. The only thing that's not possible is to have one of the little segments be bigger than the whole length, which is what this is saying. Can BC be bigger than the whole length? That's no. So that would be not possible, okay? Number 12 says 3 planes intersect in space, all right? Which of the following can describe their intersection? So basically 2 lines, 3 planes intersect. Their intersection can either be a line or a point, okay? So basically you could have something like this, right? And you have this happening like that, okay? And then maybe you have another plane over here that looks something like this, right? And it goes out this way, okay? That's 3 planes, they intersect in that line. Okay, probably not the best artist here, but try to understand that. You could also have 3 planes intersect in a point. That could be something like that. Most people look at that by, say, like a, okay, that's a bad example of a cube. Let me try to make a cube one more time. Something like this, okay? So you've got this plane here, that intersection is a line. But if I have another plane here, where do these 3 planes intersect? And they intersect in a point. So for this problem here, it's 2 and 3. If 2 angles are supplementary to the same angle, then they have to be congruent. Using the rules of strength, now we're back to logic, which is the strongest major connective? So it's either a conditional, if that's all that's offered. Nope, biconditional is all power, it has superpowers, okay? Okay, so identify the major connective in the sentence, major connective. He is wrong, and I am right, or I shall not be surprised. Okay, you see this comma? That's breaking this up, okay? So he is wrong, and this is happening, okay? This is an or, and I shall not be surprised. See this and? This is my conjunction here. So this one, the biggest strength here is a conjunction. This one is saying, okay, find the next term. Now, we actually didn't do a lot of this, but I'm going to show you how to do this. We're not going to test you on this, but I will show you this. To find the next term in this sequence, a sequence is either a geometric sequence or it's not geometric, it's arithmetic. If it's geometric, then you're actually multiplying something by each of the terms. If it's arithmetic, then you're adding the same number to each term. So if it is arithmetic, I'm going to check. I'm going to say you would find the difference between the 2 values. Like what's the difference between 1 1/4 and 1/2? So 1 1/4, that's what, 4 5/4, and subtract 1/2. What does that make? Multiply by 2 over 2. 5 minus 2 is 3/4, so that's 3/4. So that means that if I started off with a half and I added 3/4, now I'm going to have 1 1/4. And if I add 3/4 to 1 1/4, then I get 2. So it is arithmetic. And then if I add 3/4 to 2, my next number will be 2 3/4. But like I said, we didn't cover this. You're not going to be tested on it, so don't worry about that. Which would be a counter example to the sentence, all birds can fly. Hawk can fly. Penguin is a bird, but penguin is a bird, but it can't fly. All the other ones can fly, and they're birds, but this is the only one that's a bird, but actually can't fly. Okay, the next question says, which statement about the figure at right is false? So, okay, this looks like it says bx, so that looks like it says ray bx. So bx, where's bx? So this is ray bx, looking this way, contains points A and C. Well, that's true. Okay, so that works. Points B, C, and X, so B, C, and X are collinear. That's also true. X, Y, so that's a ray. X, Y, X, Y, X, Y goes this way, contains point Z. That's false. So the answer is C. But just to make sure, let's check. CX is equal to XC. Well, yes, that's reflexive property of equality. True. What is the inverse? The inverse is the not. So all brown dogs like to chase frisbees. So what would that be? If a dog, inverse would be if a dog is not brown, okay, then he doesn't like to chase frisbees. Which one is that? That's C. Okay. If point A is between B and C, okay, let's draw that. B here, here's C, A is in between. Okay, so I don't know where it is. We're just going to put it there. It says AB is 8.2 and AC is 9.7. Find BC. Well, that's just the whole length. So that's just 8.2 plus 9.7. What is that? 117.9. I got D. The next question says 3 points that lie in the same plane. Oh, those are coplanar. Okay. Collinear is 3 points that lie in the same line. How many non-collinear points determine a plane? That would be 3. The edge of a book cover. So we have a book. Okay. Here's my book. Let's try to imagine that binding. So the edge of a book, here it is a model of which of the following? Edge. Well, just a note, planes don't have edges. So I'm thinking that this edge is more of a segment, okay? Because a book doesn't go on forever, like a plane goes on forever, like something like that, okay? What is the hypothesis of this statement? So remember, hypotheses do not include the word if, and conclusions do not include the word then. So it's whatever's in between. So my hypothesis is after the word if, not including if. So it'd be this right here. It is not raining. So that's my hypothesis, that's B. Now this one is, like with the other review and this review, we've done a ton of these. So hopefully by the time you take this midterm, you're going to be pretty good at this. Now, when they say the word supplement of an angle, that I'm saying 90 minus x. Now, remember, I'm going to just do an example again. If I have a right angle, okay, and this is a right angle, and I'm calling this part of my angle x degrees, not x, but x degrees. And if this is a right angle, and this is x, this part of the angle is going to be 90 minus x degrees, okay? It's going to be 90 degrees minus whatever this was. So if this was 30, that would be 60. It'd be 90 minus 30. So when I say, what's the complement, you would say, if the angle is x degrees, then the complement is 90 minus x degrees, okay? Now, if I have a line, and I have a linear pair, two angles that add up to be 180 degrees, they're adjacent, so they're supplementary. If I call this part of the angle x degrees, then the other part of the angle is 180 minus x degrees, okay? That's what that is. So when I say complement, you say 90 minus x. If I say supplement, you say 180 minus x. So this part of the question is saying the supplement, not complement, but the supplement, okay? So the supplement is 180 degrees minus x, okay, of an angle. Now this word is means equal, so you're going to put an equal sign in. Now this, I know I just wrote over it. This says 10 more than, so 10 more than, that's, oops, sorry about that, 10 more than 9 times something, the measure of the angle. We'll call that x, because we don't know what the angle is. So in this problem, I'm not actually even talking about the complement. I'm just talking about the supplement. Okay, so you're just going to solve for x. I'm going to get the x's together. So on this side, I'm going to actually add x degrees to both sides. So 9x plus 9x plus 1x is 10x. I'm going to subtract 10 from both sides, so now I have 170. I'm going to divide by 10, x is equal to 17. Now, x is my degrees. Remember, these are the degrees. So that's x is equal to 17 degrees. What is the measure of the angle for this problem here? I guess all they're asking me is for the angle, so the angle is just 17 degrees. Just a note, on the final, I'm probably going to ask you the angle, but I'm also going to ask you the supplement, okay, or the complement if I'm talking about that. So to get this angle, of course, you would just go 180 minus 17 degrees and to get that value. Refer to the figure, point E is the midpoint. Well, if E is the midpoint, then that tells you that this length is equal to that length, right? What's the value of x? Well, I'm just going to start off by setting them equal to each other. So we have 2x plus 15 is equal to 7x. I'm going to get the x's on the same side, so I'm going to subtract 2x. So I have 15 is equal to 5x. I'm going to divide by 5. I get x is equal to 3. So right now, the first question is just what is the value of x? So the value of x is 3. The next question says, what's the length of DE, which is this length here? Just a note, it's got to be the same length as EF, people, because they're the same length, right? So plug it in. It's going to be 21. This side, oops, sorry about that. This side right here is 21. This should also be the same, but just check. 2 times 3 is 6. 6 plus 15, also 21. What is the length of DE? DE is 21. The next question said, well, what's the length of DF? Well, it's just 21 plus 21, and that's going to be 42, which is E. So the next question says, which of the following is the converse to this statement if angle A and B? Now remember, the converse is taking your P and Q and flipping it like that, okay? So if angle A and angle B are right angles, then angle A is congruent to angle B. So I should say, if angle A is congruent to angle B, then angle A and angle B are right angles. So that would be D. All right. The next question says the statement, if A equals B and then D is equal to A plus C, then D is equal to B plus C. So what they did was they took out the A and they put in the B. So that's just the substitution property of equality. There it is. Okay, if S, and keep in mind what the difference of these are. Multiplication property is basically if you have something like this. Let's see, x divided by 3 equals 10. If I were to multiply by 3 on both sides, I'd get x is equal to 30. That'd be the multiplication property. The reflexive property is like AB is equal to AB, or you could even say A plus B is equal to A plus B. Symmetric, using the same variables or values, I would say AB is equal to BA. Or symmetric property would be A plus B equals B plus A. That would be symmetric property. Transitive property says, it would have said this. This is what the transitive property would have said. If this was the transitive property, it would have said if A equals B and B equals C, then A is equal to C. That's the transitive property, all right? None of those are. Okay, this problem here says if S is the midpoint of RT, so here's R, here's T, S is the midpoint, that means that's congruent to that. RT, this whole length is 26, which makes both of these equal to 13. It says ST is equal to 4x plus 5, find x. All right, well, we know ST is 4x plus 5. We also know it's equal to 13. All right, so we're going to go 4x. I'm going to subtract 5 from both sides, I get 4x equals 8, so I've got x is equal to 2, so this is D. The next question, this is number 32, it says if M and N are complementary. Complementary means they add up to be 90 degrees. So what that would mean is one of the angles is 4x minus 3, the other angle is 2x plus 9. It says, oh, find the angles. Well, if their sum is 90, let's see, 4, 5, 6. So we've got 6x, negative 3 plus 9 is 6, plus 6 equals 90 degrees. I'm going to subtract 6. I get 6x is equal to 84. I'm going to divide by 6. X equals 1 goes in there, 2 left over, 14. So x is 14. That's not my answer. That's just what x equals. So let's see here. 2 times 14. What's 2 times 14? 28. 28 plus 9 is 37. So one of my angles is 37. Well, this is the only one that has an angle of 37, but I'm just going to check to make sure the other side. I mean, you always check, right? X is 14. So let's say 4 times 14, 6, 4 plus 1 is 5. So it's at 56. 56 minus 3 is going to be 53. So that, check. We got that. All right. The next question says, if two angles are complementary angles, then the angles, the actual angles, this angle and this angle, they're acute. They're little angles. They're acute. Okay. I mean, they add up to be a right angle, but both, if we're talking about the little angles, then they're acute. This one is saying find the value of y. This is a little bit tricky because this, I think you need 2 steps for this because y is here. Y is this angle in here, and I don't know that. But what I do know is that that angle and that angle are vertical angles. So we can do this. We can say 3x plus 6 is equal to 5x. I think that's a 6. I don't have my glasses on. 5x. I think that says minus 18. Okay, so 5x minus 18. So subtract 3x, we get 2x. If we add 18, what is that, 24? So I get x is equal to, okay, 12. Plug that in. 3 times x is 36. And 36 plus 6 is, I'm looking at this angle right here, to 42. All right, so this angle is 42, which means this angle is 42. So I guess that means that this all together here is 180, right? So if we take, this is a little bit messy, but if, where can I write this? If I take 180 and I subtract 42, what's that? 8, borrow, 7, 3, 138. So I get 138, right? So now I've got 3y minus 3 is equal to 138 degrees, because that's 138, okay? I'm going to add 3, so I get 3y is equal to 8, 9, 10, 11. So what, 141, 4, 5, 6. And ask yourself, does 3 divide into 141? If I add the digits up, right? 1 plus 4 is 5, plus 1 is 6. 3 divides into 6, so therefore 3 will divide into 141. So, running out of room here, so we're going to go 141 divided by 3, and that's going to be 3, 4, 4. Okay, so that's 12. 2 left over. 3 goes into 21, 7. 47. Okay. Y is 47. Holy cow. I don't get an answer, of course not. Awesome. None of these work. So that's 47. I got 47 for Y. Okay. All right. Next. Which of the following are true? If 2 lines intersect to form congruent adjacent angles. If 2 lines intersect to form congruent adjacent. The only way they're congruent, people, is if they're perpendicular and adjacent. Then the lines are, oh, that's true. Okay. This is true. If 2 lines are perpendicular, then they form congruent adjacent angles. Okay. If the exterior sides of 2 adjacent acute angles, so that was that other proof. That's like this. If the exterior sides of 2 adjacent, and see how these are perpendicular? That's what that's saying. Then the angles are complement. Well, all of these are true. Okay, so what's the question? Oh, which of the following are always true? Well, all of them. So we're going to say all of them. Okay, the next one says, if it is raining, then it is not sunny. The contrapositive, so that's the not, and over. So it's the converse of the inverse. So so what am I looking for? So we want to say the not. So we're going to say, let's call this something. Let's call this not. So we're going to flip it around. So we're going to say, if it is sunny, that's going to be, if it is sunny, then it is not raining. That's what I'm looking for, okay? So for this one, if it is sunny, then it is not raining. That looks like it's D. So that's going to be D. Cool. Back to translations. Okay, what is the algebraic rule for a rotation of 180 degrees? Okay, I told you, you need to memorize these, okay? So this one is negative x, negative y. So that's going to be whatever x is, it's the opposite of x, the opposite of y, okay? It's like the inverse. Okay, I get to select which one it is. So for this problem, it looks like it's C. Okay, in a coordinate plane, AB is translated down 3 and then reflected over the x-axis. Now, you guys, reflecting over the x-axis is x, negative y. That's reflecting over the x-axis. Yeah. Okay, so reflecting over the x-axis. So if I had like 3 positive 4 and I reflected over the x-axis, I would get 3 negative 4. So that's what I'm thinking in my head. But it's translated down and then reflected over the x-axis. So what are the coordinates? Okay, these are my endpoints, -1, -3, and 3, 3. Find the coordinates of A. Oh, goodness. So I only have to worry about A. Okay. So translate that down 3, down 3, down 3. So we're going to go down 3. So if I have the point, let's draw this, -1, -3. The coordinates of this, find the coordinates of the image. Okay, so there we go. So if I go down 3, 1, 2, 3, where am I? I'm at -1, -6. And then it says, find reflected over the x-axis. So now I have to do this. X stays the same. So I have -1, and then the opposite of y. So that's 6. So -1, 6, so that's D. Okay, cool. The next question says, refer to the figure at right. Okay, so we have this really cool triangle. It says, find the vertices after each translation. So this right here, -4, -2, that's telling me for x, I'm going down 4, and y is going down 2. So that's what that's telling me, okay? So I'm going to take a point. I'm gonna make this little, I know this is small, okay? I get that, but you should have the packet in front of you helping you. Okay, so, okay, it's so small. Oh, I don't know even know what these points are. This one says, it looks like, let's see here, 1, I think that's 1, 2. I can't even read these. Okay, hold on. I'm going to go back because they're too small. Okay, there we go. 1, 2. So this is the point 1, 2. This is 1, 2, 1, 2, 3, 4, 5. Right? Let's see here. 1, 2, 3, 4, 5. Okay, that looks like 2, 5. B is going to be 1, 2, 3, 4, 5. Okay, hold on. 1, 2, 3, 4, 5, 2. Ooh. That's tricky. Okay, so assuming that I got those points right, without my glasses, it's a little bit tricky, but subtract 4. So we're going to subtract 4 and then subtract 2. So from x, we're going to subtract 4. So for A, if I what was that point? 1, 2. So if I started at 1, 2, here's B, and B was what? 3, 2, 3, 2, and C is 2, 5. So if I were to subtract 4, so my new value for A prime is going to be subtract 4, subtract 4. So 1 minus 4 is negative 3. If for B prime, if I subtract 4, I get negative 1. 3 minus 4 is negative 1. And for C, subtract 4, I get 2 minus 4, which is negative 2. For the Y value, I'm going to subtract 2. So 2 minus 2, 2 minus 2, that's 0. Again, 2 minus 2, that's another 0. And then 5 minus 2 is 3. So I'm looking for that. That looks like it's this one right here. It looks like C. I know it's small. Sorry about that. Okay, the next question says, if I start with, so the next question, I'm still using the same points, but now I'm going to do this thing to it, 0, negative 5. So that means that for X, I'm going to add nothing. And for Y, I'm going to subtract 5. Okay. So going back to these right here, this is my base right here, right? I don't have to do that again. So I'm going to add 0. So this is going to be the second value. So we'll call this is problem number 40. So I got B prime prime, C prime prime. So the first value is I'm adding 0, so it's going to stay the same. So whatever values were first are first. For Y, though, now the Y coordinate, I have to subtract 5. So 2 minus 5 is negative 3. 2 minus 5 again is negative 3. And then 5 minus 5 is 0. So that's what I'm looking for. So on this one, 2, 0. I'm not seeing that. I don't know where it is. I might have not been able to read that, but I think this is B. Okay, we're going to go with B because that's what I think. I can't see it very well, but I think that's what it says. Okay. So the next problem says the vertices are that. Find the coordinates after reflection over the given axis. Okay, so again, I told you you have got to, now these aren't rotations, these are reflections. This is a reflection over the y-axis. So they're giving you this triangle, so they want you to plot it, okay? And in doing that, you can do that. So like you got 1, 2, so that's point E, all right? That's 1, 2. You've got 1, 2, 3, 4, 0, and that's F, so that's parenthesis 4, 0. And G is 5, over one more, 5, 4. So that's way up here. So that is G. Okay, 5, 4. So what this is a triangle. All right, and what they want you to do is reflect it over the given axis. So for this one, we're reflecting it over the y-axis, this being the y-axis. So I know that if this point is 1, 2, this point here is going to be negative 1, 2. So I'm going to look for that. So far for E, right, E there, E prime, prime here, I see negative 1, 2, and I see nothing else. I don't see anything else like that. Keep in mind that reflecting over the y-axis, this is your rule. It goes negative x, y. So see the x, 1 was 1, now it's negative 1, and the 2 stays the same. It's just reflecting over there. These are the easiest ones just to be able to see. So the other ones, the rotations, I would memorize, but the reflections, you could just do it by hand. This one is 5, 4. So if I go over 5, that'll be negative 5, 4, okay? And to me, this is what the answer is, looking like it's D right there. Okay, so reflecting over the x-axis, that's going to give me x, negative y. And then reflecting over the y-axis is negative x, y. So for these problems right here, you actually need to, pick a point and then see which one works. It does look to me like all these points are different. So that's going to be super helpful. So like if I just picked a point like E, okay, just pick E. E says 1, 2, all right? That's point E. And if I were to take point E and I would reflect it over the x-axis, so that's x negative y. So now I'm at 1, negative 2, okay? And then I reflect it over the y-axis, and the y-axis says, well, that's negative x, so now it's negative 1, y. So which one gives me negative 1, 2? Wait, oh, sorry, negative 1, negative 2. So which one is that? Negative 1. So that's B. Okay. Okay. So then the next problem says, if the flags on the right are congruent, all right, then what is the transformation shown? Well, a translation would be if you take one of these, if you take the shape, right? A translation would mean you take the shape and you like move it, okay? That's a translation, okay? If it's a rotation, it means that it's going to rotate, right? And usually you're rotating around a point. A reflection is, you know, it's going to look over there, and now a reflection would mean now it's going to look over here, right? And a dilation means that you're going to, let's see if I can get this, make it bigger or smaller, okay? So in this case right here, this one is a rotation because we're moving it. That's all. That's easy. Okay, sorry about that. That's just taking it and turning it. So that's just a rotation. In symbols, a reflection over the x-axis can be rewritten, we just talked about that, as x negative y. And so they want me to write that. Okay, check, did that. Okay, and what kind of transformation is this? So translucent, oh, well, it's not that. That just means something is clear, so that's no. And isometry, yes. Dilation means we're shrinking or expanding. That's not happening. And teleportation, well, I haven't experienced that yet, but I hope to, maybe someday. No, actually, I really don't want to do that. So, no. So isometry, because it's the only thing in isometry is a dilation. So you can't like shrink it and make it bigger, but isometry is just moving it all over the place. Okay, no problem. Last page. Refer to the figure at right, find the coordinates. So remember, I told you to remember this. So so this is a rotation, negative 90 degrees. That's 90 degrees clockwise. Clockwise. This is going that way. Negative. So it looks like it's dropping down. So that's negative. Okay. Anyway, what I need you to do is to memorize these. Honest to goodness, I need you to know those. Please learn these. A rotation of negative 90 degrees is going to look like this. It's going to be y negative x. Okay, I need you to just memorize. You have to memorize these. You will be allowed patty paper. Okay, granted, if we don't run out. Okay, so rotating. So if you're going to rotate these, remember the capital R is rotate. The little r is reflect. Okay, so I'm going to rotate that. So I'm going to pick one of my numbers. This looks like it's 1, 2, 3, 2. So L is 3, 2. That's L, okay? And so I'm just going to choose L and see what happens. This says y negative x. So that's going to be 2, negative 3. And this would be L prime. So which one of these is going to give me 2, negative 3? So this one, 2, negative, that's the only one. C is it, okay? The next one is asking me what? It says, refer to the figure at right, find the coordinates of a dilation. So that's like shrink or bigger. 3 times 3, that's going to make it bigger. So I'm going to pick one of my points. 1, 2, 1, 2. So that's 2, 2. Okay. And this is 2, 3, 4, 5, 6. I think that's 2, 6. Okay. I'm just going to pick a couple points. That's my scale factor. This is telling me to multiply by 3. So if I multiply this by 3, I'm going to get, by 3, yeah, 6, 3 is going to be 18. So I'm looking for that. So far, it's A, because that's the only one that says 6, 18. This is saying take it a half. So a half of this is going to be 1, 3. For P, for, what is this letter? R would be R prime. Half of that would be 1, 1. So I'm looking for R being 1, 1. R. Here's 1, 1. And I'm looking for P being half. 1, 3. Check. It's got to be D. A dilation with a scale factor of 3.5. Okay, you're making it bigger, so it's an enlargement. It's a reduction if it's less than 1, like a half, a third, a fourth. A translation moves something. Okay, and last question. They want you to draw the reflected image. I guess we're reflecting it across this y-axis. Oh yeah, across the given line. Oh boy. As you may have noticed, I'm not the best artist. But yeah, I'm thinking it looks something like that. Do better than me, people. Okay. And I think that's it. Hey, that's all I have for you. Get ready for your midterm. I hope you do great on it. Thanks so much for watching. I really hope it helped you, and good luck. Okay? All right. Thanks for watching.